Okay, I know what you're thinking. Oh my gosh, he wants us to do a lab, but he's not going to tell us how to do it? Where's the lab sheet? What data do I collect? Hey, that's what honors physics is like. You're going to have to figure out things, and then we'll go over them. Some of you may have noticed that there's a shadow here. And you know what? You cast a shadow too. You've got a meter stick. Hey, maybe there's something you can do with that. And what if it was a cloudy day and there was no shadow? Hey, maybe you can use the protractor. As we tilt the protractor, the weight stays vertical. Maybe you can aim and look at the top of the pole. Yeah, I'm giving you lots of hints, huh? Okay, well, we aren't really in school, so I got to do that. Now, I'm going to collect some data and I'll get back to you. You work on yours, okay? Okay, so you're really not here. What are you supposed to do? Go outside at your house, get your meter stick, get your protractor, and go measure maybe to the top of a tree or to the top of your roof of your house. You pick the item you are, if you have a telephone pole, whatever it is, you try to find the height of that object and collect your data. Whenever you do a lab in honors physics, you have to have a lab notebook, and you're going to have a diagram, a title, labels to the diagram, all the work showing how you're getting your answers. Now, before I get serious with my work, I'm going to just do an estimate. I just put the meter stick right there, and I'm going to back up. It's always a good idea when you do lab work to have an idea of what you're looking at. I'm going to want to have an estimate so that I can check to see if my work seems reasonable. So take a look at that meter stick and look at the flagpole, and we can have an idea of how tall that flagpole is just from that. I think I'm going to measure the shadow of just the meter stick. I mean, I could do my body, but I think the meter stick will work too. I'm going to mark the end of the shadow with my bottle of sunscreen. Sunscreen has a connection to physics as well because it blocks UV radiation, which we'll study in another chapter. Okay, so I got the meter stick vertical, and I'll go right to the cap of the meter stick. Yeah, right about like that. Okay, 1 meter tall. How long is this going to be? Looks like it's maybe about 85 centimeters. Now to measure the length of the shadow. 1 meter, 2, 3, 4, 5, and it looks like we're about 5.5 meters. Alrighty, all of that information in the diagram has to go in your lab notebook. And you ought to say something about why are we using the shadow of the flagpole comparing it to the shadow of the meter stick? Is there something going on about the diagram that we can state that allows us to make some kind of comparison? I don't want to tell you what it is right now, but you should think about it. Now, what about that protractor method? First, let's hold the protractor horizontally. The top is horizontal. I think you can see that the weight is hanging vertical. That's at 90 degrees. If I tip it this much, I've tilted it 10 degrees. So now the top is tilted 10 degrees above the horizontal. Now it's 20. Well, let's aim it right at the top of the pole. All right, like that. Now, it's kind of hard to do with one person, but we got to get an angle on that. Okay, I'm getting about 18 degrees. Well, what can I use that for? If you draw a diagram, you should be able to make a triangle somehow out of this, but starting with the height of my eye. I'm also going to need to know how far I am from the flagpole. Well, I'm going to speed things along and just pace it off. My pace is about 1 meter if I stretch it a little bit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, it's really... All right, that was about 9.7 meters.